In this video, I'll be solving trig equations of quadratic type. So this just means that, well, let's back up. If we can think back to when we learned about quadratic equations in algebra, those all had the form ax squared plus bx plus c is equal to 0. So we always had that x term, the variable, getting squared. So that's happening here. We can have trig functions or trig equations that are getting squared. And so that's what we're going to be solving here. And so if we can remember some of the methods we would use to solve a quadratic equation, we do that by factoring. We could use the quadratic formula. We could complete the square. And those ways probably get less and less enjoyable as we go down the list. So if we can factor, that's going to always be the strategy we want to use. And then if we can't factor, we can try using the quadratic formula or completing the square. All right, so let's look at these examples. So tangent squared of x is equal to -1 plus 2 tangent of negative x. Okay, so just like when we were solving regular quadratic function or quadratic equations back in our algebra days, what we'd want to do is always set this equal to 0, and we want to put it in a descending order. So we always want the squared term first, the x or the b term second, and then the c term. So I'm going to do that with this trig equation. So tangent squared of x minus 2 tangent of negative x, and then so add 1 here, subtract 2 tan negative x. So plus 1 is equal to 0. So there's my new equation. And if you can remember, whenever I have a negative angle like that, that should help remind us, well, is tangent either an odd function or an even function? So tangent is an odd function. So just as a reminder, tangent of negative x is equal to negative tangent of x. So I'm going to rewrite this equation without that negative argument. So that negative argument, it's kind of like that negative comes out in front. So I have two negatives. So plus 2 tangent of x plus 1 is equal to 0. So we have this all ready now to solve. We have it in the form we want. Now what you want to think is that we want to think about this as a regular quadratic function. So this would be similar to x squared plus 2x plus 1 is equal to 0. So if you can solve this quadratic equation, the trig quadratic equation isn't really much different. So how I would solve the algebraic quadratic equation, I would just factor this. This is x plus 1 equals 0. Set both of those equal to 0. So x would be -1 here, and it would just show up twice. Okay, so similar idea. This is going to be something I can factor. This is tangent of x. This is tangent of x. And I know that that's correct because when I multiply out, I get tangent x squared. And then it's just going to be plus 1 plus 1. So that's how we factor this. Now, because both of these binomials, because both of these factors are the same, I don't need to solve them both. I just need to solve one of them. So tangent of x plus 1 equals 0. So now this is just a boring trig equation that we already know how to solve. So tangent of x is equal to -1. And then we want to think, when is tangent equal to -1? Well, tangent is negative in quadrant 2 and 4. And this occurs when the sine and the cosine values are the same. So thinking back to our instructions, we want this to be in radians. So my x value is going to be, well, what radian measure has sine and cosine the same in quadrant 2 and quadrant 4? So it's going to be 3 pi over 4 and then 7 pi over 4. So those are the solutions. All right, let's look at this next one. It says, find all solutions for the equation 2 sine squared theta minus 5 sine theta plus 2 is equal to 0. And we're in degrees here. Now I'm going to translate that trig equation into an algebraic equation. So this would be 2x squared minus 5x plus 2 is equal to 0. Now, can this one be factored? Let's see. 2x and x, maybe negative 2, negative 1. Is that right? 2x squared minus x minus 4x minus 5. Yeah, that would be correct. So because I can factor that, I'm just going to go down here and rewrite this as 2 sine squared theta minus 5 sine theta plus 2 is equal to 0. So in the factorization that I already did, I'm just going to replace the x's with sine. So 2 sine theta minus 1, and then sine theta minus 2. So now I have two factors that I need to set equal to 0 in order to solve. Okay, so this will be 2 sine theta minus 1 equals 0, sine theta minus 2 equals 0. So solving for sine theta first, getting that isolated, I'll have sine of theta equals 1/2. Now we want to say, when is sine equal to positive 1/2? And I want this to be in degrees. That's going to be in quadrant 1, so 30 degrees, and then 150 degrees. Okay. The second branch, sine theta equals 2. The question here is, when is sine equal to 2? Well, there's nowhere in the unit circle when sine is equal to 2. The biggest value that sine ever is up here, and that's when it's 1, 0, 1. Okay, so there is no solution to that branch. So the only two solutions for this equation are 30 degrees, 150 degrees. Okay, and then one last equation here. This one's a little bit an extra step here. It says find the solutions in radians. So 2 sine squared theta plus square root 3 cosine theta. Now, one thing to notice is that we have two different trig functions here. So what we want to do is we want to rewrite this so that we only have one trig function. And that sine squared theta should make us think of using the Pythagorean identity. So I can replace sine squared of theta with 1 minus cosine squared theta. So I'm going to go ahead and do that. 2 cosine squared theta minus 1 plus square root 3 cosine theta is equal to 0. So we have a single trig function in this equation now. Distribute the 2 cosine squared theta minus 2 plus square root 3 cosine theta is equal to 0. Okay, this one looks a little more complicated, but again, this is the A term for the quadratic, this is the B term, and this is the C term. So I'm going to go ahead and write that in descending order. Okay, and looking at this, let's rewrite this as an algebraic equation. 2x squared plus square root 3x minus 2 is equal to 0. So if we wanted to solve this, we would say, well, can I factor this? And I'm not going to be able to factor that because the square root 3 is going to give me some trouble. So because we can't factor, we need to use the quadratic formula. So using the quadratic formula, if you remember, is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. So we're going to have to do that here. So the a value is 2, the b value is square root 3, the c value is negative 2. And what I'm doing here is I'm solving, instead of solving for x here, I'm now solving for cosine of theta. So cosine of theta equals opposite of b, so negative root 3, plus or minus square root b squared, so root 3 squared minus 4ac, which is negative 2, divided by 2a. So we're left with negative root 3 plus or minus square root of 3 squared is 3. Negative 4 times 2 is negative 8 times negative 2 is, what do we have here? 16 divided by 4. Let's see. Okay, so I get cosine theta equals negative root 3 plus or minus square root of 3 plus 16 divided by 4. So this isn't going to come out very cleanly here. I'm just double checking my work before I move on. So I did the Pythagorean identity, made that substitution, distribute the 2. I'm missing this 1 here. So plus 1, plus 1. So what that means is I have negative 2 plus 1. So this should be minus 1 here. So what that's going to do, that's going to change my C value. Oops. Okay, so my C value, that means negative b plus or minus b squared minus 4a. So I don't want a negative 2 in here. Let me do that in a different color. I want negative 1 right there. So does that change things? 4ac. Negative 8. This still isn't going to come out to an integer, but 8 like that. All right, well, cosine theta is going to be negative root 3 plus or minus the square root of 11 divided by 4. So my two solutions are cosine theta is equal to negative root 3 plus root 11 over 4, and cosine of theta is equal to negative root 3 minus root 11 divided by 4. I'm still thinking back to make sure I have this correct. Something doesn't seem right here. But what we want to do is we want to type this into the calculator. We're going to do cosine inverse of negative root 3 plus root 11 divided by 4. And that'll give us an angle, and we want to make sure we're in radians. And then similarly, we're going to do cosine inverse of negative root 3 minus root 11 divided by 4, and that's going to give us something also. So typing this into the calculator, let's see what we get. Again, make sure you're in radian mode. So inverse cosine of negative square root 3 plus square root 11 divided by 4. And I get 1.635 radians. And that is between 0 and 2 pi. 0 and 2 pi, that's 0 and 6.28 radians. So we are in that. That is good. And then sine So we have 2 sine squared theta plus square root 3 cosine theta plus 1. One thing to notice is that we have 2 different trig functions here. So when we see sine squared of theta, that should remind us of the Pythagorean identity. So if I subtract cosine squared from both sides, I get sine squared theta equals 1 minus cosine squared theta, and that's the substitution we're going to make. And by doing that, we end up with only cosines in the equation. So distributing, I get 2 minus 2 cosine squared theta plus square root 3 cosine theta plus 1 is equal to 0. Now, when we have a a quadratic equation, we want that squared term to always be positive. So what I'm going to do is I'm going to move everything to the right side of the equal sign. So this will now become 2 cosine squared theta minus square root 3 cosine theta. And I had a positive 2 and a positive 1 here. So I had positive 3 on the left side. So this is now minus 3. Okay, so this looks like this quadratic equation. 0 is equal to 2x squared minus square root 3x minus 3. Now, if I was going to try to solve this quadratic equation, I would first try to factor. But I'm not going to be able to factor this because that square root 3 is going to cause some trouble. So we're going to need to use the quadratic formula. Whoops. Which, if you remember, is x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. Okay? So using that for the trig equation, I'm going to be solving for cosine theta instead of just theta. So that's an important point. So we set this as cosine theta equals opposite of b. Let me identify a, b, and c. So cosine theta equals opposite of b. So opposite of square root of negative square root 3. So that'll be positive square root 3 plus or minus square root b squared minus 4. A is 2. C is negative 3. All over 2 times a. We have negative root 3 plus or minus. Negative root 3 squared is just 3. And then minus 4 times 2 is negative 8. Times 3 is negative 8 times 3 negative positive 24 here. Divided by 4, and I can do a little simplification. So I get square root of 3 plus or minus square root 27 is what we get, but I can simplify that to 3 square root 3 divided by 4 here. Okay, so that is what cosine of theta is equal to. Now, let's see. Because there's 2 solutions, or I'm sorry, because I have a positive and a negative, and sorry, I need to do a little erasing down here. I had some scratch work from before. Okay, so we have 2 solutions, right? Because one branch is positive and one branch is negative. So I'm going to have cosine theta is equal to square root 3 plus 3 square root, sorry, trying to go too fast. Let me slow down. Cosine of theta is equal to square root 3 plus 3 square root 3 divided by 4. The second branch is cosine theta is equal to square root 3 minus 3 root 3 divided by 4. Okay, so on the left side, I have 1 square root 3. I can put a 1 in front, plus 3 square root 3. So I have 4 square root 3 over 4 here. Okay, those 4s can cancel. And I want to know, when is cosine of theta equal to 3? Well, or square root 3. Square root 3 is bigger than 1. Cosine never has a value that's bigger than 1. So this branch has no solution. On the right branch, I have cosine theta. Again, this is 1 square root 3 minus 3 square root 3. So that's negative 2 square root 3 over 4, which is negative root 3 over 2 when I simplify that. So I want to know, when is cosine equal to negative root 3 over 2? And we want this to be in radians. Okay, so cosine is negative in quadrant 2 and 3. The angle when cosine is negative root 3 over 2 is 5 pi over 6 and 7 pi over 6. So there is the solution to this equation. And if we think back to what the graph looks like, I already did this one for us. There was our original equation, kind of a goofy equation, but our two solutions when that is equal to 0 are 5 pi over 6 and 7 pi over 6.